Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This is actually a nice little easy geometry problem if you know the formula. So we're going to start off solving this quickly just using the formula, and then we'll talk about backup approaches that you can try. So let me just get into the pen here, the pen tool. And the formula is just the area is 1/2 AP. So that you should memorize. So I'm going to put that in red so that you have an incentive to memorize. So the area, oh boy, that's messed up. It's just 1/2 AP, where the A is the apothem and P is the perimeter of this, in this case, it's pentagon. Now to plug in here, I'll just change colors. And so it's going to be 1/2. The apothem is 3.2. And the perimeter pentagon is 5 sides, so it's 5 times 4.6. Okay, and I'll take a minute here to put this in my calculator. So 0.5 times 3.2 times 5 times 4.6. So this gives me 36.8, and this is centimeters squared. Okay, because this is in centimeters for the apothem length. The perimeter is in centimeters, so centimeters times centimeters is centimeters squared. Another way to remember this is area is always in squared units. And that's it, so you're done really quickly. And there's nothing wrong with doing it this way. There's a lot of good things about doing it this way. If you're in class, you might have to do it this way because this is the way the teacher is instructing you to do it. So we'll take a look at an alternative way. And I actually have a pentagon shape on this platform from Wyzant here. So let me grab that, move it over a bit. I want to make it a little bigger too. Okay. Well, let's take a look at this guy. So we're going to be interested in this triangle, and the vertex of the triangle is at the center. Now you can see there'll be 5 triangles, so we just do 360 degrees divided by 5 to get that angle. So that gives me an angle of 72. And now I'm going to drop the perpendicular. This is our apothem here. But let's pretend we didn't know what an apothem is. So that 72 is cut in half, so it's really 36 here. These 2 triangles are congruent. The reason is that these two lengths are congruent and they share a common height. So HL, you might remember HL for right triangles. All you need is the the leg and the hypotenuse. So that's what we have. We have a leg here which is shared and a hypotenuse which is congruent. And this is all coming from the fact that it's a regular pentagon. A regular pentagon is where all the angles are congruent, all the sides are congruent. Okay, so now we can work with this. The side is split in half, so this side here would be 2.3 and 2.3. And so now all we need is this height. So I'm just going to change colors, give you the height here. So the area of the triangle we all know is 1/2 base times height. And so we need that height. So let's get the height. So we're going to use tangent of 36 is equal to 2.3 over height. So height is equal to 2.3 over the tangent. And I'll put that in my calculator. So just have to make sure I'm in degree mode, which I was not. I was in radian mode, so you want to fix that. So 2.3 divided by tangent 36, and that's giving me 3.16, so it's pretty much what you got in the problem here. So you can see there's another way to skin this cat. And now we can come in here for the area of the triangle, so it's going to be 1/2. So the base here would be 4.6, because now we're going after the full triangle here. 4.6 times the height, which was 3.16. And so, again, more calculator work, so 0.5 times 4.6 times 3.16 gives me roughly 7.3. And we're going to have 5 of these. So this is the triangle area, and then the pentagon area is just going to be 5 of these times 7.3. So that, my calculator is giving me 36.3 centimeters squared. So the numbers, you can see the numbers in the original problem are actually just rounded, and that's the difference. And we get the same answer either way. It's really nice if you can remember the area formula for a regular polygon, 1/2 AP, and that's usually going to be the better way to go. But if you get stuck and you just don't remember, just remember to do this. Just divide it up into triangles and then find the area of the triangles and add those up, and you'll get the same answer. So whichever way you want to go is fine. But I encourage you to memorize this formula. You'll be using it over and over in geometry, so you might as well memorize it. Okay, so that's it for this problem. Hope that was helpful, and I'll see you next time.